Hi, I am Tae-Kyu from Midas IT. I'm very glad to be here to introduce Midas Gen, window-based general-purpose structure analysis and optimal design system based on the finite element analysis. Midas Gen is used in many different areas such as stadium, power plant, hangar, airport, and underground structure. Here is the contents for today's training webinar. Topic for today is introduction of reinforcement concrete design. I will practice the multi-story for those who are not familiar with RC design and also introduce the capacity design. Then after Q&A, I will send you the email about survey. In survey, there are some questions. Also in the last question of the survey, you can check on whether you want to get certificate or not. Survey will be sent in 2 days after this webinar. If you have any question, please use the question windows. I will give you the answer end of this training webinar. Okay, let's start. Following features are available in Midas Gen for the RC structure, concrete code design, and code check of the beam, column, and wall is available. Also, seismic zone. For the seismic zone, we can perform the RC stone column weak beam design. Also, slab and wall design. For the plate element is available. For the footing, we can design the isolated footings and piled footings are available. For the steel design, we can design the general frame. Also, steel optimal design is implemented. For the steel design, I will do the training webinar in April. The following tables shows the summary of Eurocode implementation in Midas Gen, beam, column, wall, and slab design are supported for ULS and SLS limit state design. For the beam and column, we can design bending moment with and without the axial force and shear design. And for the wall, the bending and shear is available. For the slab, punching shear checking is possible. For the wall, in plate stress also we can design. In the serviceability limit state design, you can perform the stress limitation and crack control and deflection control. Stress limitation and crack control and deflection control is available for the slab. This table shows the available design code in current gen. You can see the RC, steel, SRC design code for the America, European, PS, Indian, and Canadian, Chinese, Japan, and many international building code. Those are implemented. Today we have the general session for design procedure in Midas Gen. The main purpose for this online training is to introduce some useful feature of Midas Gen, focusing on the member design for the concrete structures. Also, through this session, you can build your capability of effective implementation. The second chapter here, the purpose is to learn RC frame and wall design features. In the practice example, I will introduce the important steps from the RC design and features. Let's see the detail of RC frame design first. This shows the available section for the RC design. For the beam, you can design rectangular and T-shaped section, as you can see in this picture. Also, for the column, we can design rectangular, circular, and pipe section. And for the wall, we can design straight wall using wall elements. We can also design combined wall using plate element. We have two different functions for RC design. First one is RC code design and the other one is RC code checking. For the design, program will give you the required rebar area, size, number of rebar, and spacing. For user for the user defined sections, based on the results, you can automatically enter the rebar data to the member, or you can manually enter the rebar data as well. After that, if you made any change in rebar data, you may need to verify the member again. Based on your desired design code, you can use the check function. So after you enter your own reinforcement or make any modification, then you can perform the check. And you know whether the building or the model is satisfy design code or not. Program perform the column design by using 3D PM interaction curve to calculate the each resistance. I will introduce the mesh slab and wall design as well. This mesh slab and wall design used for the plate element. When you perform the slab design, we use the wood armor formula, which is widely used for the slab design. And we can consider the smooth movement, so slab flexure design, serviceability checking, punching shear checking, wall design can be performed. For the wall design, program provides the rebar spacing and diameter and required rebar area and required rebar ratio, and also resistance ratio can be checked. There are two approaches for modeling wall in Midas Gen. The first one is using wall element and the other one is using plate element. Plate element is often used to model wall for low-rise building, and it is possible to match horizontal and vertical direction. As you can see in this model, wall element in Midas Gen is often used to model shear wall for medium and high-rise building. With the help of the wall element, we can check design force of shear wall in convenient way. However, there is limitation that division of wall element between the story is not allowed. With this example, we will learn reinforced concrete design features in Midas Gen. This model is 6-story building consists with beam, column, and wall. I will apply Eurocode 2 for this building, and this example is intended to illustrate the design procedure for the design procedure as per Eurocode. Then the geometry creation and boundary assignment load application will be skipped. I will show you the model here. In this model, we do not include the slab, but consider the rigid as a rigid diagram. First of all, we need to generate the load combination. Go to Result and click Combinations. In this dialog box, user should generate the load combination in the Steel Design tab here to apply Steel Design function. Similarly, Concrete Design tab for Concrete Design function, load combination generated in the General tab here. are not considered for the design function. In this time, I will auto-generate the load combination for concrete. Go to Concrete Design tab here and click Auto Generation and select the code and click OK. If you generate the load combination, program automatically provide both positive and negative direction of the wind load. So user do not need to define the both directions. Also, user can modify or manually input the load combination. Uh, Using the spreadsheet form here, click this one. User can copy and paste from their own Excel file. Okay, and close and perform the analysis. Next, I will define the design code in this dialog box. Go to Design and select the concrete design parameter, design code here. In Midas Gen, we have, as I earlier mentioned, we have the many country codes. For instance, America, Europe, China, BS, Japanese, and such. In this time, I will select the Euro code and click OK. Go to Design and General Design Parameter and Definition of Frame. Select the structure braced and non-sway type with respect to global X and Y direction and click OK. Actually, remember this beam is actually one element but divided into two elements because of this cell beam. So with the member assignment function, go to Design, General Design Parameter, and Member Assignment. Click this function. We can specify these two elements as a single member. Click Automatic, select All, Beam, and click Apply. Program automatically recognize the separated member as a single member. And click Close. Go to Design again, click the General Design Parameter, and click Modify Live Load Reduction Factor. We will use the live load reduction factors to reduce the live load for column, shear wall, or foundation when calculating the required axial strength. Enter basic data required to calculate the live load reduction factor. For the first floor, to select it, I will use the select elements by identifying this function. Go to select type is the story, and I only select the first floor and input the reduction factor here. The first floor, I input the 0.82 and apply it. For the second floor, go again, story, second floor, add, and exclude the floor, and it should be 0.85 and click apply. And next, for the third floor, add, also delete the floor, and it should be 0.9 for the reduction factor and apply. Next, go to Design again, General Design Parameter, and select the unbraced length. If 0 is entered for Ly and Lz, unbraced lengths will be calculated by the program based on the nodal coordinates of the beam elements. So just leave it 0 and do not consider for laterally embraced length, and select all and click apply. Next, I will input the partial safety factor. Go to the concrete design parameter and click partial safety factors for material property. We can enter the strength reduction factor, which are a form of safety factors to account for the difference between the nominal and real strengths of the materials. Also, difference in member strengths between the design and manufacturing or construction. So, click Update by Code button and click OK. But when the strength reduction factor is not entered, strength reduction factor specified in the current design code. And click OK. Next, go to Design and Concrete Design parameter again. Click this Modify Concrete Material. In this time, in this function is used to modify a part of the steel rebar and concrete material property data entered during the creation of analysis model, or to change the material property data. So in this time, I will change the rebar data, select the Euro code, and for the main rebar, class B and class A for the sub rebar, and click modify and close. I show you one of the useful feature. Go to Tool and Preference and click the Design. In the Preference Design tab, you can define the default of design code rebar data. If you want to use the ASTM rebar data, you can just select it here to ASTM and click OK. To check it, to check the change, go to Design tab and select the Design criteria for rebars, this function here, and click this rebar. You can see the ASTM, the rebar data, is activated. However, in this time I will use the Eurocode, so go to Design tab and select the Eurocode. Click OK. And again, if you go to the design criteria for rebar, you can see only the Eurocode is activated. Okay, in this dialog box, we can enter the standard size of the main and sub rebars, which is stored up used in the design of beam, column, and brace member. Also, we are able to enter the standard size and spacing for vertical and horizontal rebar used in the design of shear wall members. This function enables the user to design reinforced concrete by assigning different rebar type by beam. For the rebar, for the beam, I will change the rebar size 20 to 20, P20 and P25, and for DT is 0.055 and DB 0.055, and DT and DB are the distance from the surface of concrete to the center of rebars. And also change the column design here. The size is the P25 and 32, and DO is same 0.55, and for the wall I will select the 13, P13, and 13 for P13 for horizontal rebar, and DE also 0.45 in this time, 0.45, And if you click this button, input additional wall data. Actually, shear wall design has the two different methods. Method 1 does not consider end rebar. This method 1 does not consider end rebar, but vertical rebars are uniformly contributed along the cross section. And method 2, 3, 4 consider high contribution of end rebar to the flexural strength. So large number of rebars are placed at the end zone of the cross section. Click OK and click OK. Next, I will perform the design for the beam. Go to Design tab, Concrete Code Design, and Beam Design. You can see the result in this dialog box here. Midas Gem provide the one-page summary report. Click this graphic and you can see the design information and section data. In section data, you can see the rebar spacing, diameter, and number of rebars. Also provide the checking ratio for the bending moment, capacity, and shear capacity. We have the detailed report as well. In detailed report, we have the strength verification results in the form of detailed calculation for the selected member. The section for design function, go to design, select the section for design, this function. Provide the member design of concrete sections based on the section data defined by the user. It allows you to find the appropriate section without reanalysis. Member design and strength verification of structural steel and concrete section based on the section data defined by the user. In this time, I will select 413, this section, and click modify. I increase the height and width, just 0.05 meter here, and click OK, and close. And go to the property, sort by property, and click this 413, which I just change it, and click recalculate. Program automatically recalculate. Select all and update rebar. By checking update rebar button, the rebar designed in this dialog box will be automatically entered into the selected sections. You can see the input data in the worksheet. Go to property. You can see the detailed input data. And you can modify here the rebar, size of the rebar, and number, as you can see here. As the beam, we can check the graphic and detail summary in the column design. So perform the column design, concrete code design, and column design. As I mentioned, we can check the graphic and detailed summary in the column design. Sort by member and graphic design with the PM interaction curve and detail report with the detailed formulas. Uniquely for the column design, you can see the PM interaction curve. Um, you can see the PM interaction curve here, applicable for the vector axial force and biaxial moment. And select all and update rebar in the workspace as well. You can see the input data for the column for rebar input data. For the wall design, go to Design tab and click Wall Design here. Using the results obtained from the analysis of the entire structure and additional design data, program can automatically design concrete wall members according to design code. As you can see, you also check the one-page summary report for the wall and detailed formula and the 3D PM curve, this PM curve. I will introduce the wall ID with detailed explanation. In order to reflect true stiffness of combined wall, individual wall elements are assigned with the wall ID. This wall ID. Member force of the wall element are produced for each story by wall IDs. If two or more wall ID at a given floor are numbered with the same wall ID, they are recognized as a single wall structure, and each element force is combined together for the force output. If the wall element assigned with the identical wall ID, as here, but located at the different floors, are recognized as the distinct wall structure. Accordingly, it would be advisable to assign the same wall ID to all wall elements located in the same plane through all the floors. For the C here, you can see different wall ID are assigned for each wall and showing the different result for each wall as well. Here you can see. In Midas Gen, the direction of the walls should be the same to get the design result. For instance, this D figures, you can see the assigned same wall ID, but the direction of the wall is not the straight line. So Midas Gen cannot provide the result for the design this combined wall. However, here the figure E, you can see the three walls in here are assigned a single and same the wall ID with the same direction. So you can assign the same wall ID, and it is available, and it is possible to see the results. Next, I will manually enter the rebar data through the Modify Beam Section Data dialog box. Go to Design and select the concrete design parameter and click the Modify Beam Rebar Data. In this time, I will change 412 this section. Change the top and bottom rebar, adding more, and then change the stirrup, the size of the stirrup. And click the Add and Replace and close. Perform the beam check. In the beam check, as you can see, 412, as I changed, you can see the graphic one page summary report with detailed rebar data and the ratio for the bending moment and shear capacity. Also, you can see the detailed report with the detailed formulas. Go to Design and Concrete Design Parameter and Modify Concrete Material. Click this function again. Click this three dot, and you can see the short long-term elastic ratio here. For the serviceability check, the ratio of the modulus of elasticity of reinforcement to the modulus of elasticity of concrete for the short term and long term can be entered. And go to Design and General Design Parameter and click the Serviceability Load Combination type. Once the load combination is generated using the auto-generation, the program automatically assigns the quasi-permanent here, the frequent and characteristic load combinations. Go to Concrete Design Parameter and select the serviceability parameters. You can define the stress parameter, control parameter of the crack, and deflection for serviceability check. In this time, I will specify some of the sections. So go to Select Type and select the section, and 411 to 422. Click Add and Apply. Serviceability check is provided for the beam member for stress limitation and crack control and deflection control. With the result of analysis and additional design data, program will automatically design concrete beam member according to design. Go to Design and Concrete Design Code Check and Beam Check. and sort it by the member and click the serviceability wizard, and then see the graphic and detail report here. Also, you can see the summary report. Thank you for your listening, and next I will introduce the slab design. In Midas Gen, slab deflection check considering the cracked section can be performed using cracked section analysis feature. In the first training webinar, I explained the procedure for general design process of slabs and walls. Therefore, today I will explain how to check cracking deflection in slabs. This is the plan and elevation view for this model. This model is 5-story building and applied code is Eurocode. 4 different loads are applied as following. I will show the demonstration. I will show the model. Just click and drag and drop the model in the program. Okay. Let's start the slab deflection check. First of all, we need to generate the load combination. Go to Wizard and click the load combinations. Select the concrete design tab and select auto generation here. Select the code. In this time, I will use the Eurocode and click OK. The load combination is automatically generated by the program. Then let's perform the analysis. And go to Design tab and Mesh Slab Wall Design and click this Serviceability Load Combination type. Crack deflection can be checked only by quasi-permanent serviceability load combination type. Serviceability load combination type is automatically classified if auto-generation function has been used to generate the load combinations. If the user manually defined load combinations, serviceability load combination type must be defined by the user. If serviceability load combination type is not specified, slab serviceability checking is not performed. We need to select the load combination for the slab and wall design. Go to Design tab and select the meshed slab wall design and click Slab Wall Load Combination. Crack section analysis will be performed for the quasi-permanent load combinations selected in the deflection cracked field. Let's define the deflection limit. Go to Design and Mesh Slab Wall Design and Serviceability Parameters. Slab length, here L, can be automatically recognized by the program as a domain length. In this time, I will select all member and click Apply using a default value. Okay. Cracked section analysis can be performed for the element which contain the rebar data. Let's input the rebar data in this model. I only input the rebar data for the 4th floor. Activate only 4th floors. And we can input the rebar data for the, as you can see, this column zone here, and remaining zones separately. I already defined 2 different structure groups for the convenience of the selecting element. Okay. Then go to design and again mesh slab wall design and click this slab walls rebar for checking. I identify the data for S1. S1 is exclude the column zone. So input the rebar data here, 150, 12, 12, 150. Okay, and add and replace. And for the S2, which is the column zone here, I will input the rebar data, change it. Okay, and add and replace. You can see the input result in the worktree. Also, using the display, this dialog box, go to design and select the subdomain rebar direction and mesh slab rebar data and activate it. You can see the S2 here around the column zone and S1. You can define it. Okay, go back and check off again. Okay, as the program used to update effective second moment of the area during the crack section analysis, convenience, the criteria and iteration number need to be entered. So go to design and mesh slab wall design and click the crack section analysis control and define 0.01 for the conversion tolerance and perform the crack analysis here. Click this perform cracked section analysis. Cracked section analysis is performed for all the slabs which contain rebar data. To check the cracking deflection, go to Design tab, again Mesh Slab Wall Design, and Slab Serviceability checking here. Click the deflection and cracked. Now we also want to see the crack point with the value. Click Apply. And again for the ratio, click Apply. Now we can check the deflection considering cracked section. deflection ratio comparing to the deflection limit is displayed in this model view. And if you click the design result here button to check the detailed result as a report, effective second moment of the area can be checked. For the direction 1 and direction 2 separately, and it also contains the deflection limit by subdomain. Select the creep here option and value and click apply to see long-term cracking deflection. So far, I introduced the slab deflection checking by cracked section analysis. Next, I will introduce the capacity design, RC capacity design. For the capacity design, I will use the similar model as previous one. Just click and drag and drop. This is the similar model as the first one. In the PPT, you can see this is the seismic design procedure. First of all, perform requirement will be determined, and then ground condition. Next, we will define the seismic action as a static seismic load and response spectrum load, and generate the load combination. And based on the regularity of the structure, we will decide the method of analysis, whether we can perform the static seismic load pushover analysis or inelastic time history analysis. After that, we will perform seismic analysis. Safety verification is also required. Finally, we will perform the capacity design with detailing. This capacity design based on the Eurocode 8 Italian code, which is NTC 2008, and American standard. In Midas Gen, we can perform the strong column and weak beam design. In capacity design, beam failure should occur earlier than column failure. Also, moment failure should be occur first before the shear failure. Ductility design can be performed for the high and middle ductility class. Midas Gen is capable to do the capacity design for the beam, column, wall, and beam column joint. Even those detailings are considered in the capacity design. In order to satisfy the capacity design rule, design moment will be determined with those formulas. Based on those to the beam, this one and this one, beam moment, program determine the top and bottom. This top and this bottom, the column design moment. For the shear force, first of all, the shear force will be determined based on the moment resistance of the beam. It means moment failure will always occur before the shear failure. Also for the column, it will use to moment resistance to calculate the design shear force. For the wall, same rules are applied. For the different type of the wall, such as the wall system and dual system, we apply the different formula according to the specified code to calculate design moment and shear forces. You can find those formula in your code. Program also considers this design envelope for the design force and detailing of the walls. With this example, I will explain the capacity design feature in Midas Gen. This model is 6-story building and consists with the beam, column, and wall. I apply Eurocode for this building. Actually, 4 different loads, as you can see here, are applied. I already input the load for the floor load, live and dead load for here, and the wind load, and static seismic load, and response spectrum. And for the bound collision, as you can see, the fixed support conditions are applied at the base of the building. Let's perform the analysis first. Okay, it is done. As previous, this beam is actually a single beam. This beam is actually a single member, as I mentioned earlier, but divided by the sub beam here. So in this time also I will use the member assignment. Go to design tab, general design parameter, and click the member assignment, and automatic all, and click apply. The program automatically make a single member, which was the divide by 2 elements. Let's set the design code next. Go to design and concrete design parameter in design code here, and in this time I will use the Euro code here and click this capacity design, check it on, and let's click these 3 dots. Set up the structure type. This is the dual system, and behavior factor should be calculated by the program, or user can input, but in this time I will select this one, calculated by program, and default function for the elastic response spectrum should be Eurocode, and click OK. And for the ductility class, I will select the medium ductility and click OK. Go to the design and click this concrete design parameter and click this design criteria for rebars. As I mentioned earlier, in this dialog box, we can enter the standard size of the main and sub rebars to be used in the design of beam, column, and brace members. We are able to input the standard size and spacing for the vertical and horizontal rebar to be used in the design of the shear wall members. In beam design, click rebar and select the size of the rebar, and also click the rebar for the column and select the size. I will use this value and click OK. Next, I will perform the ductility design. Ductility design menu is used when the user perform beam and column design for entire beam and column members in the model at once. So go to design and RC stone column weak beam select it and click the ductility design. Also, we can design some parts of the beams and column which you selected. Make sure to select all the beam and column which are connected at the joint, because design moment of the column are calculated based on those the beams. Unlike non-seismic design, capacity design take more time because the beam and column design are performed at the same time. As you can see, the program performed the beam design first and then column design. Please wait for a few minutes. And as I mentioned earlier in the beginning of this training webinar, in April, I will do the training webinar for the steel design. So please participate for the training webinar for next month to get more the knowledge and information about the steel design. And all of the question that you wonder, I will answer right after this demonstration. So please use the question window and I will answer for you. Okay, ductility design is completed. Mm, for the go, first of all, I want to show you the checking the strong column weak beam ratio. Go to design and select the RC strong column weak beam and click this strong column weak beam ratio. This function provides the fracture capacity ratio of the reinforced concrete column to the reinforced concrete beam. The joint for which the ratio is less than the acceptance limit are displayed with the ratio. Default value of the acceptance limit is 1.3. but in this time capacity ratio I would want to see all of the capacity ratio, so click apply. You can see the each members of the capacity ratio. Also go to design and again strong column weak beam, and you can see with the table strong column weak beam ratio table provide the sum of the design moment resistance and column and beam, and the ratio of design moment resistance of column to those of beam for each joint. Okay, go back to the dialog box here for the beam and column design. Beam design results are same as the non-seismic design except for the shear design. So go to member and click the detail report. So as you can see here, the special provision for the seismic design to calculate the shear force are applied here. For the column design, in order to determine the column design moment, program compare the member forces between the load combination and the capacity design rule. So as you can see here, this part, and so as I mentioned right before, the program compares the member force between the load combination and capacity design rule, and then determine more critical case. You can see they're looking for the maximum value and display here. To modify the beam and column rebar data, go back to the design column design, this dialog box, and select all and click update rebar. And for the column, for the beam as well, select all and click this rebar, update rebar. Capacity design for the wall menu is same as the non-seismic wall design. So go to design, concrete code design and wall design. Capacity design for wall can be tracked in the same manner. One-page summary and the detailed report are provided as well. See detailed formula here. Okay. I will modify the beam rebar data. Go to design tab and concrete design parameter and click the modify beam rebar data. We can also check the closed section with user-defined rebar data based on the capacity design rule. By using this function, this dialog box, you can tune the design result suggested by the program. In this dialog box, you can enter the rebar data and the concrete cover thickness for the RC beam members for strength verification. Select number 411 section and change the number of rebar to 3. I and J end is already changed. And for the 413, we change the stirrups size. So it should be 150, 200, 200 and 150. and click the add and replace. And for the 414, same. I will only change the startup here. 150, 300, and 150. Then click add and replace and close. We need to check to verify the member again. So go to design and concrete design code check and perform the beam checking. So after you enter your own reinforcement or make any modification, then you can perform the check to know whether it is satisfied or not. So you can see the modification of the rebar data is satisfied for the program. You can see the graphic rebar information and detail report. You can do the column as well. You can change the rebar data and perform the column checking to check whether your input the rebar data or modification of the rebar data is satisfied or not. Okay, I finished the capacity design, and next I will introduce the useful module and option implemented in Midas Gen, which is GSD and dynamic report. GSD stands for the General Section Design. This module is added to the Midas Civil and Gen. So GSD defines any irregular cross section, and it is applicable for RC, steel, and composite section. Also, GSD provides section property and moment curve and PM, PMY, and PMZ, and MM interaction curve. Also, calculation of the section capacity and the safety ratio based on the member force is displayed. And it also plot the stress contour for all the cross sections. These steps is using for GSD. I will demonstrate it with the program. In the program, simply go to I will open the different model. What you need to do is just simply go to just a second. Simply go to the Tool tab and click the General Section Designer. First of all, define the material. So go to Model and Material and Add. I will use the Eurocode, and you can select from the database. Click OK. And I will draw the shape. This is my own shape. Okay. And you can input the rebar data. Go to Model and rebar data. There's 5 different methods that you can input the rebar data. Just click the rebar and you can change the size of the rebar. or rebar line pattern. Just click and click. Can input the rebar with the line. And the rebar data can be changed, and number of interior rebar can be also changed in this dialog box. I can use the rectangular method for input the rebar, or even the arch is available. Okay, once you're done, define the load combination and perform the analysis. Once you perform the analysis, you can see the PM interaction curve, MYMMZ, and 3D PM interaction curve as well. And you can see the stress contour with the mesh or the axial force moment is point the maximum and minimum value. And also you can check the section property. If you want to use this section, you can import into the gen, Midas gen. Just click connect and import it. And once you go back to the Midas gen, just simply click the model and select the property and go to section. You can see what I just generate. This model is imported in the gen, and also the section property you can see in this dialog box. I also introduced the dynamic report function. Word format report can be generated for the selected input and output data such as the figure, table, graphs, and text. Using this dynamic report icons, you can change of the model file as automatically update into the report. So in this case, I will use this model, and I want to input this view in my report. So click this dynamic report images and just name it just one. And from the top view, I also want to input this view in my report, and front view 3. And go to click this dynamic report generator, this icon, and I will open the new documents. And then if you go to this report tab, you can see user defined image here. So just click and drag and drop. Sorry, the image file was not correctly inputted. Okay. Just image, and from top view image 1, and front view image 2, and then drag and drop. You can see those images was inputted in the simple way with the drag and drop. Also, if you want to input more detail of the data, such as the nodes story data, just click and drag and drop. The story data was inputted automatically, and trust data and self-weight data you can input with a simple way. However, during you do many work like modify the model and change, I will show, for instance, During your modeling, you delete this part and also delete this part. You don't need to capture again. You just go to the report editor, this tab, this view, and then click this icon, Dynamic Report Auto Generation, and select the figures and click Regenerate. As you can see, model is updated automatically with the most recent view. So it helps you to save the time to generate the reports. I finished the second training webinar, which is the concrete design. The topic for April, as I mentioned, is steel design. I will introduce the steel design feature at the time. And next is Q&A session. If you have any question, feel free to ask me. And if you have any additional question, please use the email. You can ask all of the questions through the email as well. esupport@midasit.com. Thank you so much for your attention and have a great day.